Hi, my name is Heidi Reed, and I'm a mechanical engineering student. I did my project over the application of carbon nanotubes. Basically, a carbon nanotube is a microscopic tubular structure made from carbon that is naturally woven together in this chicken wire pattern that you see here. This is a molecular model of a carbon nanotube. Basically, the orbs that you see here, right there, represent carbon atoms, and these rods between them represent the bonds between the carbon atoms. This chicken wire structure makes a carbon nanotube an extremely stable, thus an extremely inert compound, and it also creates a super strength within it. When formed into sheets, they can hold up to 50,000 times their own weight. They're 17 times stronger than Kevlar and carbon steel, and they're 5 times stronger than spider silk. Another cool thing about carbon nanotubes is that they're extremely good conductors of electricity. Some of the uses involving carbon nanotubes include solar cells, cancer treatment, super strong materials, artificial muscles, semiconductors, invisibility, space study, and so many more that are still being developed. So basically, the topics that I'm going to be covering are cancer treatment, super strong materials, and invisibility. First, cancer treatment. Cancer has been defined by mechanical engineers as a disease called mass transport dysregulation, which means that the cells that form cancer are in the wrong places, and they basically need to be put back to where they are, or they need to stop being transported and produced. Current treatment that is specialized for cancer right now doesn't fluctuate as the blood system fluctuates. Therefore, the treatment can't be released at the proper times. However, with carbon nanocapsules, which are made from carbon nanotubes, the treatment is able to be released the right amount at the right time. Thus, when a cancer cell is sensed by a carbon nanocapsule, or when an imbalance in the blood system is sensed, the carbon nanocapsule can actually release the treatment at the right amount at the right time and stop releasing it when it sees that the balance has been restored. The second application I mentioned was that of strong materials production. First, I have to mention that any material produced with carbon nanotubes is referred to as a resin, and by weight, only 1% of these resins needs to be composed of carbon nanotubes in order for the resin to exhibit the same properties as that of carbon nanotubes, such as being able to support 50,000 times its own weight. This property makes them extremely lightweight, low cost, and easy to mass produce. In addition, since they can still support up to 50,000 times their own weight, this makes them an extremely big development in the production of safety materials. They're also less brittle than metals, so when they break, instead of forming sharp shards like glass or crumpling like a can, they make more of a sheet, such as tempered glass. This increases actually harm reduction because they break like tempered glass. The third is a rather strange one, the invisibility cloak. It's allowed to do this because the index refraction for light for carbon nanotubes is close to the same index refraction as that of air. It's so close so that when submerged in water and heated up slightly, it actually makes them appear invisible. I've actually found a video that illustrates this property, and here it is. Now it's gone, now it's there. The invisibility application has actually been predicted and used more for military applications rather than any civilian applications, so it's not likely that we'll be able to have any type of invisibility cloak available for civilians. However, it's a huge military advancement. And in conclusion, basically, carbon nanotubes have endless, very strange, unusual applications, many more than the ones that I've been able to mention in this report. They have applications anywhere ranging from medical applications to military applications and solar cells, as I mentioned, and even semiconductors. There's still more applications that are being found to this day, some that are being developed still, and basically the three that I covered are the ones that I found the most interesting. That of invisibility, which, as I said previously, will be used in mostly military applications. Strength and safety productions, which can be used anywhere from protective clothing to automobile safety, and cancer treatment, which, strangely enough, can be applied to the mechanical engineering field, as I pointed out in my cancer treatment slide. So basically, to sum it all up, carbon nanotubes are an extremely innovative, unusual, but very useful thing that mechanical engineers and many other engineers are currently researching and developing. My next slide here is just references. If anybody would actually like the references, they can email me or ask me for them, but other than that, that's my presentation. Thank you.